Welcome back to the lecture series of hydraulic structures. So today we are discussing about phreatic line or the seepage line. In the earlier sessions, we have discussed about the dam and the different elements of a dam, types of dam, and also the types of failure of the dam. So in this particular session, we'll see what is seepage line, what is phreatic line, and what are the how to determine the phreatic line and why it is important to determine the phreatic line. Determination of phreatic line. This is phreatic line by Casagrande's method. So what is this phreatic line? It is also called as a seepage line, saturation line, or hydraulic gradient line. See, this is a dam section. Okay, so there's water in the upstream side. There's an impervious foundation, and there's pitching or the slope on the upstream side. The water seeps from the upstream side to the downstream side. If there is no filter here, this top flow line, or which is also called as phreatic line, will flow through the downstream side like this. So, but it will saturate the soil here below the downstream side, and it will cause failure of this downstream phase. Therefore, a drainage filter will be provided here at near the toe. This drainage filter will, if the drainage filter is provided, then the phreatic line will pass through the cut the drainage filter, and the water gets collected in this drainage filter, and so that the toe area is protected. So why we have to determine the seepage line? The seepage line is determined to estimate the seepage through the dam. So we can draw the flow net after getting this seepage line. We'll discuss about the flow net later on. It is the flow net, so therefore it has to be determined. Phreatic line separates saturated zone from the unsaturated zone. So below the seepage line or the phreatic line, the zone is saturated. The zone is saturated with water. So above this, it is unsaturated. So there will be pore pressure below this. Positive hydrostatic pressure exists in the dam below the phreatic line. So above the phreatic line, there will be zone of capillary saturation where hydrostatic pressure is negative. The flow of water below the phreatic line reduces the effective weight of the soil. As a result, the shear strength of the soil is reduced due to generation of the greater pore pressure. So what happens here is, if this is the seepage line, so below the seepage line there is pressure in the upward direction. There will be pressure in the upward direction, whereas above the phreatic line there is a negative pressure. So because of this pore pressure which is from the bottom, which is positive in the upward direction, it reduces the weight of the soil. The weight of the soil is acting downwards. So this, because of this negative pressure, then the weight gets reduced. So when the weight gets reduced, the shear strength of the soil is reduced. The saturation line should not strike the downstream face of the dam. So we should see that, therefore the drain of is provided at the downstream face of the dam. So to determine the phreatic line, so we understood what is a phreatic line. It is nothing but the top flow line, and below this is the positive pressure, above this is the negative pressure. This is the saturation zone. This is the unsaturation zone. On the phreatic line, there will be atmospheric pressure. So this pressure, pore pressure from the bottom reduces the weight of the soil which is acting downwards. Therefore, the shear strength of the soil will get reduced. That is why we have to see that the phreatic line should not pass through the downstream side. Therefore, a drainage filter here will be provided. So, let us see how this phreatic line is determined. So, it is a parabola. So, if you see this curve, it resembles a parabola. Part of the parabola, the parabola will continue like this. Is a part of a parabola. So for that we should know the properties of a parabola. So what is the property of the parabola? If this is a parabola, F is the focal point. F is the focal point, and a line which is outside the parabola at a distance of S. This is the focal length. This is the focal length. S is called as the directrix. So the property is if you consider the property of the parabola is like this. If you consider any point on the parabola, so A is a point I have taken on the parabola. The distance of that point A from the focal point. What is this distance? This is nothing but AF is equal to the distance of that point from the directrix. So this distance is AB. So FA is equal to AB. Same way, if you consider any point D, FD will be equal to DC. Similarly, FG is the distance of this point G from the focal point. It is equal to GE. So if you take this as distance as P, this distance is also P. So if you take XY as a coordinate of this point A, take xy as a coordinate of this point A. So this distance is Ex and the vertical distance is Y. I'll just erase this. So I'll try to draw neatly. So this distance is X and this distance is Y. And this distance is x30 plus x square plus y square. X square plus y square. So this distance AF is x square plus y square because it is a right angle triangle. So if you take FA is equal to AB, the distance of the point A from the focal point is AF, which is equal to the same distance from the directrix AB. So FA is equal to AB. So or if what is FA? FA is x square plus y square. That is what I've substituted here, x square plus y square, which is equal to AB is what? This is X. This distance is X. This distance is 2P. 2P. So it is 2P plus X whole square. So if you solve this, so X, Y is the coordinate. This distance, this one you have to take it as Y, and this will be Y square minus of 4P square divided by 4P. There's a small correction here. Okay, so before drawing the flow or flow net is the path of flow of water in the dam. Flow net for the earthen dam section, it is necessary to plot the phreatic line more accurately. So after drawing the phreatic line, you can draw the flow net. Flow net is the path of flow of water inside the dam. So then with the help of this, if this is the dam, with the help, this is the dam section, so you have to plot this flow net. Then you have potential drops across the flow net, so you will get line of equipotential line. So this particular thing is called as a flow net. So to draw the flow net, you need this phreatic line. So there are two methods. One is Casagrande's graphical methods, and the other one is called analytical method. So the graphical method, you can determine the phreatic line for a dam with and without horizontal drainage filter. So as I told you, we have to provide the horizontal drainage filter here in order to see that the phreatic line do not cut the downstream side, so that it will cut the drainage filter. So there are two methods. One is the graphical method, the other one is the analytical method. So first we will discuss Casagrande's graphical method. So it is assumed that the phreatic line, Casagrande assumed that the phreatic line is a base parabola whose focus is at F. So this is the focus F, which is at the starting point of the filter Fe. So this is the embankment here. This is the embankment. Okay. And this is the depth of water in the reservoir. And F is taken as a starting point of the parabola. To determine the phreatic line, the procedure followed is like this. So first what you have to do is, what is AB? AB is the upstream phase and H is the depth of water. Let L be the horizontal projection of this phase AB. So just draw a line starting from, draw a vertical line here, and this will be the horizontal projection of this AB. So mark a point C at a distance of 0.3 L on this horizontal line. So we know that F is the focus point of the parabola. Using the principle that the distance of any point from the focus of the parabola is equal to the distance of the point from the directrix. So you have the focal point of the parabola. We have to determine the directrix. So in order to do that, what we'll do is, from the point C, you measure this distance CF. Measure the distance. You take a point C, measure this distance CF. With CF as radius and CF as radius and F as a focal point, you draw an arc which will cut the directrix at the point D. This is continued. This is projected. So you, with C as center, F as a focal point, draw an arc. So it will cut at D. So at D you draw a tangent line. At D, where it cuts it, you draw a tangent line. So this is nothing but your directrix. So from the principle, what is the this distance? CD will be equal to CF. The distance of the point C from the focal point and distance of the point C from the directrix is same. Okay. So now you have located the point D, and G is the point which is in between F and H. H is a point where the directrix cut the filter. So G is the starting point of the phreatic line which is in between F and H. So how do we locate the other points? So we'll see here. So I'll repeat once again. So AB is the upstream phase. Let the horizontal projection be L. Okay. Then on the water surface, measure distance BC, which is equal to 0.3 L. Then the point C is the starting point of the base point of parabola. To locate the directrix of the parabola, use the principle that any point on the parabola is equidistant from the focus as well as from the directrix. So hence, with the point C as a center, CF as radius, draw an arc to cut the horizontal line CB at the point D. So with C as radius, with CF as radius, C as a center point, draw an arc, it cuts here. At D, you draw a tangent. So CD is equal to EF. So hence the vertical line DH is the directrix. This line is the directrix. Then the last point G on the parabola will lie in between F and H. To locate the intermediate points on the parabola, use the principle that the distance from the focus and the directrix must be equal. So, for example, if you want to locate P, you draw a vertical line through P. And with F as the because the coordinates are x and y, this is the distance x and this is the distance y. Measure qh is what? Qh is the distance of this point p from the directrix. So now qh should be equal to QH is its distance from the directrix. From the focal point, this distance should be, that is from FP should be equal to your QH, or this distance. This distance is nothing but QH. The point P, this distance, how will you get this point? This FP. FP will be equal to QH. So with F as the center and QH as the radius, draw an arc to cut this vertical line. Draw an arc. So you will get the point P. Similarly, you can consider another point. Draw a vertical line through this, and with this distance, say if you take this as Q dash, if you take this as Q dash, and this distance Q dash H, and this distance should be same. So with the radius as Q dash H and F as the focal point, draw an arc to cut this line. So where it cuts, you will get the second point P dash. So this is how you can continue. And since C is not the starting point of the phreatic line, so phreatic line should start from the point B. So you will get some points here like this, and this point can be drawn by freehand so that there is no kink. So now this is how you get the phreatic line, and it should meet the point. The parabola should meet, the last point should be G, and the starting point should be B. This is how we draw the phreatic line. So now we can also calculate the ordinates of any point on the phreatic line using the equation of the base parabola, or how to estimate the discharge. So consider any point P. On the parabola with coordinates xy and with respect to focus F as the origin. So with respect to focus, yes, you consider this point. So what is this distance? PF will be equal to QH. This distance PF will be equal to this distance from the property. So what is this distance? This distance is x square plus y square. It is a right angle triangle. And this distance is nothing but your x plus the focal distance S. Distance of this F from the directrix is taken as S. So x plus S. So if you take this equation, the same equation I have written here, squaring on both the sides, x square plus y square is equal to x plus s whole square, which is expanded as x square plus s square plus 2xs plus 2x. Yes. So from this, x square and x square will get cancelled. So you can get an expression for x, which is equal to y square minus s square divided by 2s. This is a x coordinate. And y square is equal to 2xs plus s square. This is the equation of the parabola. So this you can get it from this expression, or this expression, y square is equal to s square plus 2xs. This is the equation of parabola. Or you can write s is equal to, from this equation you can write s is equal to x square plus y square minus of x. This, from this expression you can write x square plus y square minus of x is equal to s. S is what? S is the focal distance of this parabola from the directrix. So if you take at any point C, what is the value of x? X is equal to d. This is x coordinate from the focus point. This is d. And this distance is h. This distance is h. So substituting at the point C, what is s is equal to root of x d square plus h square minus d. Okay. Next. So if you want to calculate the discharge per unit length of the dam, discharge per unit length of the dam, so we have the discharge equation as per Darcy's law. Q is equal to KIA, where I is the hydraulic gradient and K is a constant, A is the area of cross section. So you are, if this is the embankment, you are taking at one particular section at the point P where the coordinates are x and y. So this is your y. If you want to find out the discharge through this particular point where the coordinate is y, the area is y into 1, because we are taking unit length of the dam. You are taking unit length of the dam. So K, hydraulic gradient is dy by dx, area is y into 1. So partial, we know this equation, the parabolic equation we know, that is from this y square is equal to 2xs plus s square, or y is equal to root of 2xs plus s square, that is written here, or root is taken out and it is written in the form of power, that is y is equal to x 2xs plus s square whole raised to the power of half. So r, partially differentiate this to get dy by dx. Dy by dx is given as s divided by 2xs plus s square whole raised to the power of half. Substituting the value of dy by dx in the discharge equation, k dy by dx is s divided by 2xs plus s square whole raised to the power of half into y. What is y? Y is 2xs plus s square whole raised to the power of half. So this term and this term will get cancelled. So you will get q is equal to ks. So this is the discharge equation through the body of the dam. This simple expression. This expression for computing the rate of seepage discharge through the body of the earthen dam in terms of focal distance, yes, it is in terms of focal distance, yes. The distance, yes, can be determined either graphically or analytically. The distance, yes, can be determined. You know how to distance. There's an expression for yes. So from that equation, we have the expression for yes here. Yeah, this distance. So you can find out analytically at any point the distance of the focal if you know the coordinate x and y, or you can determine graphically by measuring. So analytically, considering c as a coordinate, the value of s can be obtained from the equation, because at C, if you want the this thing, the discharge, So the discharge will be S is equal to root of d square plus h square minus d, or Q is equal to Ks, or Q is equal to K into d square plus h square whole raised to the power of half minus of d. By using this equation, if the value of coefficient of permeability K is known and the focal distance S are known, the discharge Q can be calculated. This gives an accurate value of seepage rate and is applicable to such dams which are provided with horizontal drainage filter system, but can also be used for other type of dam sections. So this is the discharge equation. Q is equal to Ks, where S is the distance of the focal of the parabola, focus point of the parabola, which can be determined analytically as well as graphically. So next, phreatic line in earthen dam without filter. The position of the phreatic line in the earthen dam without filter can be determined using the same manner as in the previous case, same way, but here the focus point is taken as the lowest point of the downstream side. This is taken as a focus point. So same procedure. So CF is taken and an arc is cut. So you will get this point D, and then a tangent is drawn. So that will be your distance. Yes. Okay. That will be the distance. Yes. So same procedure has been followed. So therefore, the bias parabola BJC cut the point J on the downstream line and extended beyond the limit of the dam, and is indicated by the dotted line. The seepage line should emerge at the point K, because this point should be tangential. This correction has to be done. JK, the correction has to be done. Therefore, the correction JK by which the base of the parabola need to be shifted downward can be determined by graphical or analytical method. So, this BK should be the phreatic line. Okay, so this is so in this particular session we learned how to draw the phreatic line for dam section with filter and without filter. Thank you.